Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about the computer that I built in a live stream, linked down below, but it's in Hindi. And this video is specifically which items I selected and why I selected them. So more of like a guide, and it should hopefully help you to figure out what to buy for yourself. Now, one thing I have clarified, like many times people ask me like what to buy. I never say that, specifically in Camera Tuesday. Is the primary reason for that is that I do not know your need. What exactly do you need? I don't know. For that reason, I am not a good person to tell you. Like nobody is. Other than you, nobody else is. My job is to give you the tools that hopefully allow you to make that decision yourself. So what was my target? My target was not too expensive, but it has to be cost effective. Meaning I was not that constrained in money wise, but I was constrained in terms of like, don't go YOLO on it. Like, price to performance ratio, like good value was my core target. Now that costed me around 2,25,000 rupees. If you're not familiar with that rupees term, just think of it this way, $2,700. Now be mindful, can you build a better computer than this, like what I have built in $2,700? Absolutely. But you have to be in different country. And again, you can build a worse computer if you are in different country. For example, if you are in Pakistan, this amount of money will barely buy you old graphics card. So keep that in mind. So do not freak out too much. I'm just giving that dollar term as a context awareness. Hopefully that will give you some appreciation. So appreciation as in like your country, like, but you may have expensive food. So win some, lose some. So core focus was on energy efficiency. Now this is a critical aspect. It's also a core focus for people who are building servers, people who are building office supplies. Why the heck that is? And again, specifically for people who are working from home, it matters a lot more than you think. Now, primary reason why I am so focused on it, hell bent on it, is because of dirty power. I do not live in a place where the electrical connection to my location is top quality. So we have a lot of brownout voltage, meaning I'm supposed to get 220 volt. I may be getting 180 volt continuously, meaning that's it, that's all I'm gonna get. So that creates a scenario of bad power. So how do I tackle it? Well, my energy comes to this puppy. This puppy is basically an inverter. So this takes that energy, charges the battery, and then it feeds the power to my house. Basically this whole sector as in like my house has two inverters. One is for top floor, one is for this ground floor. Now this has two batteries, lead acid batteries that are 220 amp hour. This is just photo of 150. I have 221s, and this is my 2 kVA inverter unit. Now it does have a UPS setting, but all it does in UPS mode is just that if it detects voltage low, it directly sends from inverter. Problem with that is that most of the time my voltage is low. So if I turn this on UPS mode, it will be discharged permanently. So I have to have it in what we call basically normal inverter mode. Benefit, very long run time, like big ass battery equals long run time. Consequence, it does not filter the quality of power. Basically, this sort of inverter come UPS units are what we call backup power. Then this power goes to, like this is sine wave, thankfully. That means if you are running it for a long time, it will not fry your equipments. This is sine wave. Then this puppy goes into my UPS. UPS is APS-C, backup 1100 kVA UPS, kVA I'm saying, sorry, VA UPS. Now that translates to around 600 watt actual power. Now, interesting thing with this is that if 180 is coming, this puppy will charge the system, but it will dump 180 to my electronics. This receives that 180, bumps it up to 220, and then gives clean power to my CPU. This is my limiting point. 1600 watt is more than good enough that I can actually buy something big, but problem would be runtime will be reduced, and not to mention this also has to run lights, fans, and all that jazz. So this is the reason. Now you may be like, I live in a place where I have very good electricity. Good for you. I'm happy for you. Not everybody has that. Now, the only way I will ever solve this issue is that I go with full solar. That is next target, but it's gonna take some time. So that's why core focus was that my computer has to be powerful, but has to be as energy efficient as possible. Like no questions are, I need to be as energy efficient as possible. Meaning this puppy should be able to handle my computer at least for a few minutes. And this puppy should be able to handle my computer for a few hours. So I cannot go like, 1490 Ti, like, yeah, my UPS will be like, bro, boom. And the inverter would be like, yeah, your backup just went from 4 hours to 1 hour. So for that reason, I had to focus on energy efficiency. Now, what do I actually do? Like, what is the end goal of this? End goal is video rendering, meaning I capture video and I render that puppy. And since I have already built the computer, I can tell you the rendering on my old computer, which was FX8350, worst bulldozer processor ever. Like used to take around 30 minutes for a video. Now I'm taking 6 minutes. So fundamentally better. And not to mention, if I increase the resolution from Full HD to 4K, the gap will be even exponential. So That was my core target, video rendering. Live streaming, I live stream every Saturday, but not in this channel, on my Hindi channel. Maybe I'll do live streaming in this channel, but my hope is that I will also go into game streaming. Now, last time I tried to do game streaming, flat out my computer was like, bro, I can't do this. And I'm talking about a game, Raft. It's a Steam game, Raft, but holy damn, the game is very stylized, very low fidelity. But my CPU and GPU, like GPU is good. Like GPU, I had 1070, but like my CPU was like, I can't handle this. So my target is this sort of power that I'm adding right now should allow me to run a game in good enough resolution, good enough quality, at least 120 FPS, simply because my monitors are full HD 120 FPS. This monitor is 4K 120 FPS, but you get the point. Like I want 120 FPS, and I should be able to stream without, chugging along. So that's my need. So we selected the first thing. The first thing I selected was this puppy. Basically Ryzen 9 7900 non-X. Now the critical aspect of this is that this puppy has 12 core. More core, better, quicker video crunching. So I needed more core, and it had 24 threads. So really, really fast and efficient system. This costed me $525 in India, basically. Put that in your own context. And the primary reason for choosing this is that I did not need to spend money on the cooler. The box cooler that this comes with is more than adequate enough. And given the fact that I have run it and run like video rendering out of it, it's cool. It's like, I got this. Now, it also comes with what we call Cooler Master AMD Wraith Prism Cooler. It also has RGB for some reason, but it has it. And I worked my ass off to make sure my computer is anti-RGB. Nothing. It has no RGB. At least I disabled all of them. So that's the whole point. Now, why this exact processor? One thing you have to say, since energy efficiency is the core aspect, Intel has nothing on it, flat out nothing on it. This is from LTT. You can see 95 watt power consumption from Ryzen 9 7900X. So this is the power line. Okay, good, awesome. Here's the power line when you jump to 7900X or 7950X, basically if you jump to 16 core and all that. So power went almost double. Now here's the, it goes up again if you jump to i9 13900K. And at this point in time, Intel does not have that much productivity power, flat out not. It's like barely better, but power goes up to like 290 watts sustain, and it can surge up as high as like 380. So it's bonkers, flat out I cannot do Intel. And you might be like, what about i5 and all that? Yes, can I buy Intel processor that goes as low? No. This is a graph from Gamers Nexus. Gamer Nexus? Yeah, I have linked the video down below, and you can see that this is the energy efficiency of this puppy, 7900X without overclocking, meaning I have not unlocked it, quote unquote. Basically, I'm running on the TDP lock, so this box cooler can work. How much work it can do per unit of electricity, that's there. If I unlock it, it comes here. Here's basically i9 13900K, which has 8 power, basically performance core and 16 efficiency cores. Meaning this puppy consumes electricity like there is no tomorrow. If I tried this on my system, my UPS might actually go boom. I'm not even joking. So that's the reality of it. That's why I could not even touch any Intel system. And here's the deal. By the time I have i5, which is like, somewhere here, i5 12400, again, 1200, I had to go back to that one. It will get whooped. It will get whooped by 7900. So flat out, there was no option for me to do something with less amount of energy on Intel, which is ironic given the fact that Intel says efficiency cores, like flat out, like any graph, any brand, any review, all of them comes to the same point, is that if you are running a computer that is for long duration, because this computer like that I'm using, it's work from home device, it's gonna be on for like 8 to 10 hours per day, I'm gonna go bankrupt if I've touched Intel, flat out. Remove the energy efficiency issues, remove that constraint that I have to run on inside battery backup. It's bad for all of you. And not to mention, because this place is air conditioned also, that extra heat, like, instead of 90, I'm going that like, 280, that extra around, let's say 190 watts of heat, it's becoming a heating element for my air condition to cool continuously. So my air condition bill also goes up. That's why I specified 7900 is awesome, especially for office workers. Now, you may be like, what about the time saved? Time saved is barely few minutes and your energy bill is in X. So efficiency you are gaining, like in terms of time efficiency, few minutes, and you are burning twice as more power. So it's not cost effective. Basically, that's the reason why I selected this exact processor. Like here it is, and like AMD, Intel i5 12400. Intel 12100, that's 4 power core. AMD R7 7700, it's like Intel is just here, so that's why I had to select this. And this is an AM5 board. Hopefully, I'm hoping, knock on wood, knock on concrete, is that when AMD makes even more energy efficient processor, hopefully I should be able to just plonk it right in without too much hassle. And this has DDR5, meaning my RAM should be safe for at least one cycle, so around 4 or 5 years. And then I have PCI 5.0, which I know for a fact that's going to be stable for a very long time. Why? PCI 4.0, while we jumped from it, but you have to understand this, like server industry kind of leads us, and server industry is like PCI 5.0, they jump to different ecosystem. If I'm not mistaken, CXLI or something like that. Completely different ecosystem, just jumped there. Because again, at some point, signal integrity becomes so hassle that copper cannot handle it cost effectively, so to say. So PCI 5.0, DDR5, these things are here to stay for some serious amount of duration, meaning I'm not gonna be poofed out of existence anytime soon. And it has iGPU. Now this also helps me that if in future I would like to build a network attached storage or things of this nature, having iGPU makes my life exponentially easier. And this also gives me a line of redundancy in case my GPU malfunctions. At least I will be able to do everything that I am doing. So again, that's why I said this processor, like for all the companies, be mindful 5000 series also had this, but they never made it available for public. It was always available for OEMs, basically Dell, HP, Lenovo. So this is the first time a consumer can buy energy efficient parts. So I'm happy with this puppy. So work done per unit of power, GG. I give you 2 units of power from solar. This puppy is like, I got this. Run Intel on it. Intel is like, bro, no. And his deal, what if I become rich? What if I become energy rich also? Then I can just go into precision boost overdrive. The end. This puppy, I have to add a liquid cooler and done. This puppy will literally bitch slap any processor at that point in time, right now. So very good, wise investment. Then we come to the motherboard part. While the processor was like as cost effective as I can make it, this is the part where I've kind of spent a bit. This puppy, basically, I spent a bit of money in this. The reason for that was I wanted something that kind of lasted, because again, till this point I have built around 2 computers, so to say. One was assembled, another was like I built, but I always been like, on the lagging edge, never on the bleeding edge. This is the first time I had the opportunity and I jumped into it. So AM5 again, DDR5 again, PCI 5.0 NVMe slot. You can buy that for very low cost. I did that, but PCI 5.0 16x slot for primary GPU, that's the reason why this motherboard is kind of overpriced, but I had to do that. And 670E is the chipset name. Now be mindful that there is actually only one chipset, that is 670. 670E means there are gonna be put 2 physical chipset, and those chipset will allow like basically one lane, so to say. So one PCI 5.0, another PCI 5.0, those 2 chipset. Benefit, chipsets are low power enough that you do not need fans. That's why there is no fan on this motherboard. Thankfully, hopefully, this means this puppy can work for a few years without any issue. Heck, the warranty itself is 3 years. 3 years. So this puppy costed me 32,000, and I could have spent a bit more if I wanted Wi-Fi. I did not wanted Wi-Fi, so I did not spend on that. So that translates to $390 in India, and full 16x slot is the reason why I have future chill with this. Meaning, I know for a fact that when NVIDIA is gonna release the 5000 series, they're gonna have PCI 5.0, and my motherboard will be like, bro, I got this. Don't worry about it. I know the next generation of NVMe SSDs that are coming out right now are PCI 5.0. This puppy is like, I got this. So this is where I kind of spent, and not to mention I already selected TUF graphics card. So I was like, how about I like have TUF. So I looked into it. And RAM wise, this puppy can support RAM overclocking. If I go bonkers overclocking, it can support around 6400 megahertz. I don't need that high. I only need 6000 because that's the optimum for 7000. Realistically, I'm not gonna overclock that much. My target is around 52, because at that frequency, it matches the Infinity Fabric. Most energy efficiency work can be done at that point in time. So that's will be my next target on that. Optimum for 7 series. And it has 2.5 gig NIC, network attached storage into it. So which is not god tier, but not bad. And not to mention, I do have PCI slots, which are PCI 4.0 slots. So more than good enough if I actually want to add 10 gigabit or even like 5 gigabit. If I want to add it, it's not that big of a deal. So it has one port that is 20 Gbps port. Damn. It has 4 10 Gbps port and 5 Gbps port. And I'm just talking about the backplane. And like this felt so wrong when I'm plugging all my ancient hardware, basically my keyboard, my mouse. I have very cheap ass keyboard and mouse, so connecting 2.0 port to this like feels wrong. I'm buying basically PCI card, not a card so to say, just a holder that uses the onboard header to give me 4 PCI 2.0 USB 2.0 ports, because I do not like the idea of plugging like 10 Gbps ports with freaking USB 2.0 ports. So I want to do that. And this is the pictures that I took in live stream. Like this is the first time I'm using a basically non-pin based CPU, because my last one was FX8350, which was pin. So this is like Intel. I connected this. It does look cool. I can guarantee you that. Like once you actually hold the processor in your hand, it looks cool. I'll give you that. It looks cool. So this was my motherboard, and not to mention this puppy is thick. As in like when I'm plugging in RAM in my old Asus motherboard, it flexes. Like it feels like I can just squish it. This puppy has multiple layers. I think if I'm not mistaken, 8 layers. So when I'm plugging in, the motherboard is like, bro, I got this. I got this. It feels tough. So this part, again, you can cut money on this, but I just wanted to have a bit of peace of mind. This is the first time I'm building a system where I'm no longer like, bare minimum. I'm like, I wanted to splurge a bit. Then we come to the daddy, the big daddy, RTX 4070 Ti. Now, why 4070 Ti? Well, that was the cheapest. And I'm not joking, like many people are actually paying more than this puppy for 3070. Like, what are you smoking, my man? Like you need help if you are doing that. So this costed me 88,000 rupees. That translates to $1070, $2. My last GPU is 1070. So non-overclocked edition. Be mindful, tough. To this day I do not get it. Like why the heck one core like 4070 Ti core can have like freaking 5 boards to it. Like there should only be 2 boards. One board designed for the most efficient operation, another board bonkers overclocking. Nothing else in between should need to exist. It's just like, do you want energy efficient or do you want bonkers? The end. But they have 5 boards. It's like, why? And not to mention, price cap is very bonkers, like 4070 Ti. This one is 88,000. The normally available one was like 1 lakh, basically 100K. From 88, it went to 150K. It was like bonkers, 88K to 150K. Same processor, 4070 overclock. I'm like, what the hell? The core is not gonna magically change. And not to mention, with modern cores, you can't really overclock them as much as you could have done in the last one. So this was really stupid. So this is a 12 GB variant. Now be mindful, I used to be a game artist, so I know for a fact that 12 GB is no longer enough, simply because people, when they are designing for PlayStation specifically, it has what we call direct memory access. Again, that technology is there in basically Microsoft, is there in like, DirectX 12 and all that jazz. It's never integrated, but PS5, they had like 2-3 years of experience on that. So when they are porting games, they're not optimizing the game as it should be. Because be mindful, 12 GB VRAM is more than good enough. It's just that nobody's porting for it properly. So you have a video game, low setting, 8 GB, everybody is happy. Moment you go to 4K and you increase the texture resolutions, the VRAM is like poof. That's why anybody who's buying 3080s, they are suffering a lot, simply because VRAM is only 10 GB. Now, like, the VRAM is slow. Trust me, having slow VRAM is far more preferable than having VRAM that runs out, because the moment it runs out, it will trigger a software crash. So for that reason, and I'm jumping from 8 GB, I would have wished to jump into 16, but 8 to 12, more than good enough. And not to mention, last generation only has 10 GB as normal, so I'm happy with this. 192-bit bus width, which is almost same bus width as I had like with my basically 1070, but consequences like 400 and basically 504 GB per second. You could buy other 30 series card which has more bandwidth. Now, if you are doing something specific, some sort of specific crunching where that bandwidth matters, it will matter. Most of the time, most of the games, it won't. So this puppy, basically, this GPU can crunch any 30 series card, including 3090 Ti in most cases. Some scenarios 3090 Ti will win simply because it has 24 GB of VRAM. So if they really need to spread out their wings, that puppy is really good. But overall, from 3070, 3080, 3080 Ti and all that jazz, most of the time this puppy will bitch slap all of them. So this was another thing, because just after buying this, 4070 was announced. So I'm not that sad about it, because again, this does give me the freedom that is like, no, nothing in 3000 series can come close to me. So that's good. And the primary benefit for that, this is far more energy efficient, meaning frame FPS per watt is much better on this puppy compared to any 30 series cards. And this also has lower surge. 30 series was the worst card in terms of power design, meaning power surges was always a thing. Like even my 1070 series has power surges, but it was always like minor surges. Well, the power supply would barely even notice it. 30 series was so brutal, so bad, and not to mention the X was very high, meaning surge went from 600 watt consumption to 600 extra watt consumption. It's like, what the hell? And that triggered overcurrent that literally drained the power supply. Basically, you are grinding its basically capacitor away, literally, not even joking. Like, it puts physical strain to put that sort of surge power. So many of them tripped, lot of issues happened. This has much better power characteristics, meaning if it says 250 watt power consumption, it remains at 250 and surges barely touch 360 rather than kilowatts of surge power. So much better in terms of power wise, and that's why I had to do it. And again, if I buy a 2-year-old series, I'll get 2-year less upgrade. So upgrade, awesome. And I need AV1 codecs. That's why I specified video game. If you want to do encoding, you have to do hardware encoding. This puppy has AV1, and YouTube has already announced AV1 import, so to say, and soon they will have export also, meaning the people who are receiving the video feed, they will also be receiving in AV1. Right now they are getting VP9, but YouTube can digest in AV1. So having this hardware built into my system was a necessary requirement. That's why I could not, even if I'm getting very cheap, let's say 3080, I will not do it. Not to mention the VRAM alone is like no. So that's why 4070 Ti was my purchase, and I'm not that mad about the fact that 4070 is now out. Not that bad. Like power draw I have seen, and I can underclock this a little bit and get almost same kind of energy efficiency. So what were the auxiliary things? Well, auxiliary things is basically first RAM puppy. Unfortunately, when I was buying this, I did not pay attention too much. Like it was not even available, so I could not have done much. Is that Intel? You have to understand there is two standards for RAMs. One, you have JDAC, another is unlocked standard. So JDAC, whenever they built it, they will build it like DDR3 only goes as high as, let's say, 1200 megahertz. DDR basically 5, let's say 4800 megahertz. That's it. So anything above that is overclock. So you can look at any motherboard box and they will always specify the JDAC unit would be the unlocked one. So the JDAC unit is on this puppy 5200. Basically, if I'm going to 5200, I'm not overclocking. But the moment I start to cross that, I'm reaching a point where I'm going above and beyond. To solve this issue, how the heck you're gonna do handshake? Manual overclocking was always a solution, but it's risky and people don't like it, and especially don't like the voiding warranty part. So companies build up an ecosystem which is Intel XMP. Now it's Intel. That's it will work amazingly with Intel. But what will AMD do? AMD built their own ecosystem, which is AMD Expo. Unfortunately, when I was buying this system, which was like 2-3 weeks ago, it was not available on the vendor that I was looking into, MD Computers. So I had to buy this. Now this has all the speed, all the specs, and not to mention, this is also verified equipment list, basically. QVL, qualified vendor list. So I went into the website of this company, this motherboard, specific this model, and looked into QVL. This RAMs module was supported. So I bought into this. However, I have not fine-tuned everything. I have not updated the motherboard BIOS. So this puppy is running at like 48 megahertz, 4800. This puppy can easily go to 6000, and 6000 is like the optimum. I do not need to push further than that. And it does have like very thick heatsink, so I'm pretty sure it's gonna last. But like I have no idea who smoked enough weed to put so much RGB. Like I have to install Corsair IQ software just to disable the goddamn RGB. Like the RGBs are bright. I can guarantee you this RGB is consuming at least 1 watt of power. And I'm like, bro, people have servers that have sleep down mode that works on like 4 watt of power, and I have 4 watts of RGB goddamn LEDs. So I don't like that, but it is what it is. So this costed me around 18,800 rupees, around $230 in India. You should be able to get it cheaper, or maybe something wiser, but that's it. And in terms of SSD, I went splurge a bit here also. It is 990 Pro. This is the highest I can get for PCI 4.0. What about the crash that's happening on lifespan shortening? Because again, unfortunately, Samsung did release a firmware that was buggy and that was destroying the SSDs. Not physically destroying it, it was just writing corrupted data, and the controller was thinking the NAND was actually corrupted. It was not. It was a sad situation, but they rectified it, did a warranty RMS and all that jazz, and I'm old enough where I've seen this sort of thing happen to every company. So I don't even care. And not to mention all other variation. Other companies literally have like AData and all the other brands. It's like, yeah, this is the SSD, awesome. You buy the same SSD 1 or 2 months later, it's like, yeah, this SSD is not performing. Yeah, they changed the controller. Yeah, they reduced the NAND flash quality. Compared to that, I'll take this. And not to mention every other brand that is doing long-term testing, server industries, they're like, nothing comes close to the Samsung's reliability. Now, why is that? Because it's a vertically integrated product. You go to any other brand, be it Western Digital or basically Asus itself, or Gigabyte itself, you'll always find controller from someone else and NAND flash from someone else. This puppy, everything is from Samsung itself. So that's why I trusted it. And not to mention every brutal test you can do on this, it will keep going, keep going, keep going, and all other SSDs will fall apart, flat out. So this is the most oomfish SSD you can get for PCI 4.0. In 3-4 years, they will release for PCI 5.0, then I can jump there. Then we have come to the power supply, this puppy. Now here's the deal, me and my brother was kind of helping me build this system, so he kind of urged me to not go into Corsair 800, Corsair I think, 800 watt power supply. I wanted that power supply simply because it had platinum rating, meaning it was far more energy efficient. Not that much energy efficient, but bit more efficient. But he wanted me to, like, if I'm going bleeding edge on everything, PCI 5.0, DDR5, everything, so go into a system that has PCI 5.0 power delivery. So this puppy. Now this puppy, I do not know whether it can truly match up the ATX 3.0 standard, but this does have PCI 5.0 power, and because it's a 1 kilowatt unit, as in like 1000 watt, it has full unlock capacity, meaning 600 watt can be sent through that 12 volt high power rail system, meaning there should not be any GPU that should hurt this puppy. Like, this puppy should be like, put whatever GPU you want, I got this, whatever GPU you want, and it still should have enough room for a processor, even an Intel processor. Although I think Intel processors, some people have overclocked it and they are drawing more than 400 watt. So yeah, I will not trust it with Intel processor, but for AMD, that's more than good enough. So this is the basically power supply wise. So these are the auxiliary. So this was my presentation on what components I selected, why I selected, cost and all that jazz. Hopefully you guys have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.